Okay, so let's actually look at what question 2 is doing. So basically we want to run every line inside main, and for each of these parts, we want to figure out which method it's going to call or execute in this code, right? So we have two classes here. We have commit and we have merge commit, which is a child class of commit. And right now we're instantiating two objects. So what I like to do with these is to actually just notate. I'm going to try to have this on the same view. Okay, so com is going to have a static type of commit, or yeah, static type of commit. So let me just denote that. Okay. Okay, and then dynamic type is going to be merge commit. So this is actually an example from project 2, or yeah, project 2 Get Lit. So this is the parent class, and this is the child. And then for merge, its static type is merge commit. Its dynamic type is also merge commit. Okay, so now that we have these two instantiated, let's start running each line. So com dot equals com. At compile time, the compiler is going to check the static type of com, which is commit, look inside the commit class. I wish there was something that I can use to, okay, maybe I can just use my mouse. So it's gonna look inside the commit class and look at whether there's an equals method that takes in some commit argument. And there is, right? Precisely, it's method B. However, notice that this argument type is actually object, not commit, but that's okay because object is the overall overarching type for any object, and commit is just one subtype of that. So we're upcasting from commit to object, which is totally fine. So it's going to take a screenshot of this exact method signature. And then at runtime, we notice that the dynamic type of com is actually merge commit, right? So we're going to go inside the merge commit class, see if there's an equals method with the exact same header, public boolean equals object 0, object O, sorry. And then if there is, in this case there is, we're going to execute this method instead. And so we're actually going to be executing E. Okay. And one thing to note is that because we were working with non-static instance methods in this case, and actually every method in these two classes are non-static instance methods, we're able to do this dynamic method selection or overriding. However, if any one of these were static, for example, let's say equals was a static method, so public static boolean equals, in that case, we would have to go with the compiler's screenshot, even though the dynamic type is different from the static type. So the overriding is only possible because we have non-static methods. For part B, again, the compiler is going to take a screenshot of method B, but again, we're going to be executing this method, method E, at runtime. For C, merge has a static type of merge commit. So at compile time, it's going to go inside this class, see if there's an equals method that takes in this case, a static type commit argument parameter. And there is, right? So this equals method takes in an object. Again, we're upcasting from a commit to a type object. And so that's fine, which is why we're going to be taking a screenshot of this method E. And then at runtime, we discover that merge has a dynamic type that is the same as its static type. So that's okay, right? We don't need to do any overriding. So we're just going to be executing method E. And similarly for D, it's the same procedure. And the reason why we can still execute equals on a static type merge commit argument is because, again, we're just upcasting from merge commit to object. Object encompasses all of these customized object types. All right, and now we go on to part E. So com.compare to com. So again, at compile time, we look inside the commit class, which is the static type of com, and we see if there's a compare to method that takes in another commit static type parameter. And there is, precisely method A, right? However, at runtime, we discover that com has a dynamic type of merge commit, so we go inside merge commit, see if there's a compare to method with the exact same signature that we screenshotted at compile time. There is, and precisely it's method C, right? So we run C instead of A. And similarly for F, it's the same procedure because merge is actually a static type merge commit, but a merge commit is the child class of the commit class. So we are upcasting from merge commit to a commit type in the parameter here, which is totally fine. Okay, so we will be screenshotting this method at compile time, and then at runtime, we will again be running this method C. And so notice that you might have thought that it's method D, but it's not. That's because, again, we're only looking at methods with the exact same signature as was screenshotted during compile time. Although this would make more sense since we're passing in a static and dynamic type merge commit object, we have to find a method that has the exact same signature as was screenshotted during compile time. So this is going to be C as well. And now for G, merge.compare to of com. So merge is static and dynamic type merge commit. So at compile time, it's going to go inside this class. It's going to look at a compare to method that takes in a static type commit object. So that's method C, right? And then at runtime, there's actually no overriding because the dynamic type of merge is the same thing as its static type. So this is just going to be C. And then last but not least, yes, really last but not least, because we actually have part I after this, merge.compare to merge. This is again going to go inside the merge commit class at compile time, look for a compare to method that takes in a merge commit static argument, right? So in this case, we care about the static type of merge, which is the merge commit. So instead of going into method C, we're actually looking at method D now. And then at runtime, we discovered that, well, the static and dynamic type of merge is the same, so we don't need to do any overriding. So we're just going to stick with what this compiler screenshotted, which is method D. And then finally, we have this casting from com to a commit static type, but really that doesn't do anything if you think about it, right? Because com static type is already commit. So this is just doing com.compare to com. So at compile time, it's going to go inside the commit class, look for a compare to method that takes in a commit static type argument. This is method A. And then at runtime, it's going to discover that we need to go inside the merge commit class and see if there's the same exact method signature inside the merge commit class. And there is precisely method C. And so that's exactly what we're going to run. Okay, so again, I just want to emphasize one more point here. If any of these methods were static, you would not be able to do any overriding, okay? For that particular method, I'm not saying just because one method is static, you can't do any overriding for any other methods, but because all of these methods are non-static, we're able to do this overriding,